Please help me in welcoming Bryan Dods this morning.
Thank you very much. I want to thank the organizing committee for inviting me to come speak to you all about a topic I'm very passionate about with smart manufacturing. I go back probably 15 years of really getting in depth, but even back to the beginning of my career, I started off working in non-destructive testing. And at the time, we were looking at how to embed different sensors into manufacturing processes to do in-process real-time monitoring. So that goes back even close to 30 years now. So what I want to talk about is really the value of being in part of this manufacturing network. And so what's the value of being a node on the manufacturing network? So I know this is AeroDef, and you guys probably don't know a whole lot about GE Power. We build big industrial utility scale power generation equipment, gas turbines, steam turbines, gas reciprocating engines, the full works. So within GE, you're familiar with our aircraft engine business. I work in the biggest part of General Electric, which we generate more than $30 billion in revenue. And we just closed one of the largest acquisitions in GE history with the acquisition of Alstom Power. That was completed in November. So we now have over 65,000 people working in GE Power. So what is GE Power all about? Why would I leave an aerospace industry company and move to something like power generation? There's 1.3 billion people in the world that don't have power, and that's what we're trying to do within GE Power. That's our mission, is powering the world and bringing light to people that don't have it today. So GE, we operate across, we're a much global company, and you can see here that we provide over a third of the world's power generation capacity. So the new GE Power, this is building off the acquisition we just completed and how we're organized. So we have our GE Power Systems business, which is the old traditional GE that you're probably familiar with, the gas turbines, steam turbines, and generators. That goes back 100 plus years, located out of Schenectady, New York. With so many installed units that we have out there, and these machines run for 30 years or more, we have a very large power services business. Next is our steam power business. When we brought Alstom on board, they have superior steam power in the world. They really focus on a lot of nuclear power generation. And so we've broke that out in its own steam power business. We have a distributed power. So what's going on today in the world with a lot of emerging countries, unlike in the US where we have large-scale centralized power, a lot of the smaller or emerging companies are looking at distributed power. So how do you get smaller units, 4 megawatt, 10 megawatt size machines? So we have an aero derivative business where we take an aircraft engine, we'll put a power plant behind it and have it available for power. And like in Japan with the tsunami there, when they had all their nuclear knocked out or shutting them down, we were able to send over temporary power and get them up and running within about 6 weeks and provide the country some power with our distributed power business. We have a large joint venture with Hitachi for nuclear power, and that is coming back. We are building nuclear power plants here in the US and across the world, so a lot of new things going on with nuclear. And then one of the surprising facts that I found about water usage, 50% of the water consumed here in the US goes to cooling our power generation plants. And so that's why the water process technology is in our business. So thinking about why is GE interested in smart manufacturing and what we call the brilliant factory? Well, I mentioned before, we're very global, and this is our new, footprint in more than 120 countries, and more than 100 different sites. So how do you manage something like that? We're looking to get all these factories connected, give our leadership visibility in what's going on across the globe. A lot of work moves around depending on how jobs are bid. So these aren't real stagnant factories. They're very dynamic. The work that's moving in and out of there, the equipment that's moving in and out, and the people that run these. So how did we get into it? What was the history behind of what we call the Brilliant Factory? And in my career, almost spanning 30 years, I've never had CEOs that talked real positively about manufacturing. But Jeff Emmelt's been a whole lot different. So in 2014, he had his very first blog that he came out with that year, talks about how we're going to digitize our factory and make them smarter and more connected. He even mentions about how we're going to use high performance computing. And these are all things I've been talking about for 10, 15 years. And I'm getting really excited about what he's talking about. So we think about, with the Brilliant Factory, 4 different things, or pillars as we call them, as to what makes up that Brilliant Factory. From integrated design, we've moved into advancing our use of CAD geometries and CAE type tools, and how you move those downstream from just the engineering organizations. We talk about advanced processes. Everybody hears about additive manufacturing, but we're also leaders in ceramic matrix composites and a world of other technologies that we're developing out of our global research centers and scaling up in our different businesses. And then we have our Brilliant Factories. These are all about connecting up the machines on the shop floor, sensing on the shop floor, and making it visible for our leadership to make decisions on closer near-time scales. And then the biggest challenge that we have, and I think we're very much like the aerospace and defense industries, where 80% of our hardware and our product content is built by our suppliers. How are we going to help digitize our supply chains? So that's what's making up our Brilliant Factory. That's what we're working on today to cover the big picture. So we started off talking about the industrial internet and the things that make up this industrial internet. And we actually did some acquisitions and brought in a gentleman from Cisco, Bill Rue, and set up a research center in San Ramon, California, where we're doing a lot of our GE digital business. And these were the pillars behind what they set up there. The Internet of Things, of course, that's Cisco. Bringing Bill in, he gives us an entire perspective on how that works at the consumer level. Now we're trying to figure out how we're going to industrialize it. We keep talking about the digital industrial company. All our machines, we're not just talking about our shop floor machines, but all our power generation equipment. We have our own control systems. How do we make those machines that are operating in remote sites smarter for our customers, and also where GE can apply some of our long history of how these machines operate to improve customer performance. Big data, I'm going to talk a little bit about all the different types of data, not just big data. I think that's a tough topic to cover. And then analytics. How do we begin to put together and make sense of all this data? Because it's streaming at us so fast, as Debbie's mentioned. Manufacturing generates more data than just about any other industry. It's just we can't consume it or haven't made the effort to figure out how to consume it yet. So in my world, this is Bryan Dods' view of our next generation advanced production system, concept of operations. So I start at the bottom here. I was a small M manufacturing guy, and that means I was an equipment and process guy, never a big manufacturing systems person until much later in my career. And so, as I mentioned, I started off in non-destructive testing, so the sensing part of it, and that was very familiar to me. And now these sensors are much more robust. Before, they wouldn't ever last in a factory floor environment, and you had a lot of sensor degradation issues. And today, industrial string sensors are not a problem. When you think about up on the data management side, this is where I think we need a lot of effort. People talk about analytics and the big data side, but we're getting hit with all different types of data. So in manufacturing, especially if you think about the old concept of SPC and Six Sigma, that was based on single point inspection, you know, micrometer, or even a CMM taking point data. Now we have data that we can do a trace, you know, we can do a surface scan and come up with a point cloud. We even have four-dimensional data when we start talking about computed tomography, where we have X, Y, Z, and a thickness. So how do we start to combine this data? Now and then you start thinking about streaming data that's coming at you. You think about pixelated data or video images that are coming at you. How do you begin to merge all this type of data? When it was point-to-point data, we did a pretty good job, Six Sigma. We're going to have to get much better at signal processing, and I think that's sort of the next stage beyond where we're at with Six Sigma. You know, another topic I want to talk to, I could talk for an hour on just this one slide, but modeling and simulation, it's another passion, as Debbie was saying in my bio, but we tend to talk about it in the universities and the concept of manufacturing, just modeling and simulation. And I want to put a little emphasis on it doesn't really drive any improvement until you link it into the controls. And so that's why I have modeling, simulation, and controls here on one line. Just a personal story that's come up with some of the network activities. So about 10 years ago, you know, the Zigbee standard, the ad hoc sensor network standard came out. And I got really interested, and we were you know, doing some pilots in different factories on that. And you know, it's sort of bounced around. I'm not sure how much it's evolved in the industrial scale, but I'm trying to get my daughter interested in some of the automation work that I do. So I go and I buy one of the home automation kits. And these are all built on, you know, the Z-Wave or some type of Zigbee standard. So you guys are starting to see these things now in the consumer market. It's very easy to get employees engaged using that type of approach and start to explore possibilities in your own factory. And then just working up into the ecosystem and the business processes side, the one thing that we have to do here is we have to connect into the ERP systems. That is where you're going to capture the value of all the smart manufacturing stuff. Doing it standalone on a machine tool is great. The machinist might get some value out of it, but you're never going to capture that and turn it into a value proposition across your business till you find a way to link into the ERP system. And then really the thing that I like doing and coming to these conferences about, it's a cultural shift that we're doing. I found that's probably the biggest challenge in my job these days, is getting people to embrace these big changes. So how do we empower people to become more than what they've ever expected they could become? And these tools get people engaged. It gives them another avenue to explore what they can do and how they can participate in the smart manufacturing space. So I want to throw some crazy, some more realistic possibilities out here and just get you thinking about what you might see around the show today and how you might incorporate it into your manufacturing operations and get on this journey to smart manufacturing. So I reside in Greenville, South Carolina, and so it was natural for me to work with our manufacturing operations there in Greenville. Now Greenville is a 1.5 million square foot facility. It's the largest gas turbine manufacturing facility in the world. And so we've had a pretty big challenge when we got started. And manufacturing, they're not going to give you access to the machines right from the get-go. So we had to come up with an approach, and I called this my outside-in strategy, and I really learned it from Dr. Jay Lee at the University of Cincinnati, who was running the Intelligent Maintenance Systems Center at the time. But we started looking at how we can improve plant infrastructure and operations, things like compressed air, industrial gases, HVAC systems, just starting with those. We began that journey, and before you know it, we had some fortuitous happenings in our factory that put us front and center with some of the capabilities that we had put in place, and we were saving, you know, 6 figures here and there every time something came up, and before you know it, we're saving the factory every year 7 figures annually. So they've really gotten behind it. So this is their strategy, how they're going about doing it. You can see they have emphasis on monitoring machines and cutting tool life and all the different plant infrastructure systems, and RFID tracking materials. And so this is their vision of how they're implementing the smart manufacturing. They're well down the path in this journey. This is really the model factory inside of GE these days, and this group's done a terrific job. So that's a good place to get started. Like I said, it doesn't impact operations. It typically results in some significant savings out of the box, and you can get your feet wet and get some experience. Some of the crazier things, if many of you work much around machine tools and that, I say machine tools are already high-performance computing environments. They have dozens of sensor or microprocessors on them already. They're parallel processing, you know, the commands as it is. But thinking about what's the next generation of machines, how do you link modeling and simulation and all the big data that's streaming off of that? How do you digest it fast enough that you can make decisions down in real time? So if you're living in manufacturing day to day, you need to have a decision within the takt time of your factory, whether that's in seconds or minutes or hours, which depending on the size of product that you're making. But most people aren't considering the takt times that we have in our factory when they're talking about big data and running the analytics on it. So how do we get the HPC environments down onto our factory floor? How do we develop the modeling tools, the simulation tools that are going to allow us to process this data to make these decisions as close to where they're going to be made valuable as possible? So you think about just a standard machine tool. You know, we already have modeling, simulation of the cutting tool, engagement with the workpiece. We have our simulations of the tool path. We have a number of different tools that we use in the back offices of our factory, but we never deploy them out onto the shop floor. Next thing is, how do we begin to build a more open machine control? Because all the machine controls are very proprietary. We can't even figure out what some of the microprocessors are in the machines, you know, because it's all proprietary code, but we'd have to open that up. We can develop a high-performance type controller that can process both the machine controls and the modeling and simulation information, and find a way to fuse that data together, different data fusion and signal processing that needs to happen. So how many more microprocessors are we going to put on machine tools? I don't know. We may be like automobiles where they have hundreds of microprocessors on a car now. All right? And so where are we going to go with the next machine tool technology in this country? May we actually win back some of the machine tool work. Different concept on maybe supplier quality. So, you know, these supplier certification programs and the, SBC, Six Sigma programs that we did so much of in the 90s have really run their course. If you're having suppliers that aren't hitting your Six Sigma objectives, then you got to really look into your sourcing practices. So the capabilities of our supply base has come up. Now what's the next step that we're going to take? We already get them within the goalposts. And so what I'd propose here is now we can take advantage of some of the 3D modeling work with the product manufacturing information embedded in it, and start really utilizing the variation analysis tools more than just up front in the program, but throughout the program, even using it day to day on our shop floor. We can take advantage of of all the 3D measurement technologies and being able to take these point clouds and merge them back onto the CAD model and really look at what is each supplier's contribution to variation of our product, and let them compete against each other to make to be sort of a self-improving network. So they're each playing off of each other to improve their quality of their own product and reduce the variation of our product. So with gas turbines, one of the biggest things that we're challenged with is reducing the clearances and the sealing that you have. Any type of loss there reduces our efficiency tremendously. So what we're trying to do is get these suppliers, we tend to work about an order of magnitude tighter than what you do in the aerospace and defense industry. Very tight tolerances that we're trying to achieve here. So trying to think about how we could compete suppliers to improve where they're already working within the goalpost. And then what GE is really good at, and what we've already started on the path, I've already talked about the GE digital piece of the business and the digital industrial piece, but it's all about changing our business model. So with this new GE digital business, we've taken what we've had as our GE Prophecy and industrial controls business, we built that all together, and we've really taken it another level higher by developing this Predix platform that gives people the ability to build applications on top of a platform that's built for the industrial user. So just yesterday, as I came in here, I've already had two companies come up to me and said, "Hey, we're building on the Predix platform already." So that's great to hear. And this is really what's changing the business model for our customers. We have close, in just GE Power, I know we're gonna target 30 or 40 different customers getting up on the Predix platform just this year. And last year was really the launch of it. We have 3 or 4 working on the platform now. So those are just possibilities, and the possibilities to me are endless. I don't know what's going to be out there. I didn't know what the internet was going to turn into in 1995, and I'm amazed every day at the capabilities that we have. So not try to predict the future, just go with it for the smart manufacturing side, and let's see where it takes us. So to the foundation of what I wanted to talk to today, how do we value being a node on the network? And this has been something I've been struggling with, challenged with since we started doing this, because we're all connected, right? But I never sit down and do an ROI on why I have a smartphone or why I have cable in my house or things like that. But in the business side, we're challenged every day to demonstrate the value of what we're doing here. So, at our GE holds a Minds and Machines conference every year now. You can go out and take a look at it on YouTube. There's some great presentations out there. It's a large event and really scaled for the industrial user. So, Jeff Emmel gets it. He's like, we're collecting all this data, but we're not creating much value from it. So how do we take the connectivity piece of it and then build off that and build the business values for it? So how do we build up this industrial internet? Networks are natural. We've been doing it since the beginning of time with trade routes, with our river cities, with being on the rail line, having an airport as a hub. All these things have been critical. We work in networks all the time, and these are very natural things for us to do. And what's holding us back on the manufacturing front? And today it's no longer a technology issue, but it's, to my point before, it's more of a cultural issue. So We all live in nodes. We feel that bigger nodes are better values, and we should feel more natural in doing this in our own operations. So what's changed in the last 30 years that I've been working? And I think the biggest thing is as we've gone wireless. So with all these other types of networks, they were all physical networks. Whether an interstate network, you had to travel from one city through another to another to get to your final destination. Airlines, now you can hopefully have a direct flight to some, but some you might have to go on one or two different stops. But all those physical networks had some type of inefficiency in them. And now with the networks that we have going wireless, all the different devices that you can put on those networks, these untethered networks have broken the bonds that we had before. So they're more flexible, but they're more complex. But to me, they offer greater opportunity, more individuality. You can bring your own mix and ideas to the industrial internet, to the smart manufacturing workplace, and implement these things in relatively short time. These don't take 1 to 2 years to demonstrate. And with some of the things, as far as getting sensors and that, we can typically run these trials in a matter of weeks. So it's not a long-term endeavor that you're jumping into when you're just trying to get started. So the value, GE has a number of economists working on this, and they've put a value of $8.6 trillion by 2025, twice the value of the consumer internet. And you know, we want to be a part of it. We want to be a big part of it. We'd like to be the platform that the digital industrials work off of. So that's one of the things that we're trying to make available to everybody, and we think there's a large value that will come from it. Now, I'll tell you, there's another, if you want to get started, there's another group out there called the Industrial Internet Consortium, and this thing has grown tremendously since they started in the middle of 2014. They have about 260 members. They have more than a dozen pilots up and running. And you can just go on and search for the Industrial Internet Consortium. And they're doing a terrific job in writing the specs, the standards on which we're going to build the industrial internet. So there's ways to get involved through that as well. And so this shouldn't be real hard, right? Demonstrating the value. This has been demonstrated, as I said, for centuries of what being on the network is worth. And in the 50s, it began to gel around telephones, and in the 70s around faxes. And there's a gentleman by the name of Metcalfe who has an empirical law, Metcalfes Law, that basically states that the value of the network is the square of the number of nodes on the network. And so this isn't something that we need to prove. We can take this. There's because it's empirical law, it doesn't have a rigorous proof behind it, but there's ways that we can go out there and demonstrate it through pilots using this type of approach. Where this law has probably taken on the biggest use, and you probably all follow it, but with Facebook, with the different satellite services that you get, the number of subscribers. That's how the financial analysts are valuing these companies, is based on this law, and they determine whatever their proportionality coefficient is when they figure out the number of nodes. But that's probably the limit of what we have to figure out here, is what is that coefficient that we multiply by the number of nodes on our network. And it's exponential, right? The more nodes that we get on there, the bigger benefit we should see. So with a lot of the smart manufacturing discussions that I hear about today, it's dominated by predictive maintenance, right? That is, guys, that's just the beginning. That's like step one. That's what we should be doing today. All the machine tools already have that capability. And if you haven't engaged that, you've been throwing money away for probably 5 years. But what is going to generate the value is connecting one machine to another, or one factory to another, one supplier to another. That's where the next stage of this whole smart manufacturing thing is going to go. And what I'm looking forward to is creating new capabilities, things that haven't been thought about yet, right? So competitive advantage, that's all going to be about creating something that's difficult to detect and duplicate, some new capability that I could walk my competitor through the shop floor and they walk out the other end and wonder, how the hell did they do that? That's what we're trying to do here. That's what I'm trying to do with all this connectivity capability. So, to me, I think the value of the network, what we need to figure out here among ourselves is what's that proportionality constant as far as hooking up all the different machines on the network, and how are we going to state that as some type of value case. But it's natural. We're all doing it. Right? Now we got to go through some exercise to put a dollar figure on it, but that's just an exercise. It shouldn't be very difficult. Everyone's going to have probably a different approach on how they do that in their own factories, but we got to get started. So to just conclude, something very simple on how you can get started, get down this path. The first thing is go out and get connected. Go out, get your machines on the shop floor. I don't care how old they are. There's boards out there that you can plug into an old controls and start getting data off that machine. Start exploring what you can do with it. Any of the new machines that have been sold in the last 4 or 5 years all have some type of connectivity that you can link into. The next thing is make this data visible. If you put it in a database, it's gone. The ability of some of these software tools to help you visualize your databases is incredible, and they bring a different interpretation to what you can just do mathematically and with a line chart. Right? So start to find ways to visualize your data. And there's all sorts of software companies out there selling that capability today. Then the analysis. This is where I think we're going to need a new skill group inside the manufacturing engineering space. We're going to need computer scientists. We're going to need mathematicians that can help us build these algorithms. There's not going to be a set algorithm that you're going to put on your machine that's going to tell you how to fix everything or improve everything you want to see fixed. You're going to need to have these people with those talents down on your shop floor, not sitting in an ivory tower IT space somewhere that's remote, but helping them get the feel for the manufacturing floor. So this is a group of people that we've never recruited in manufacturing. And how are we going to make it interesting to them? So that's the analyze piece. It's going to take a little bit of a culture change and a little bit of skill mix change to make this productive. Optimization. Once again, mathematicians are going to be critical in helping us find ways to optimize our operations, especially with all the different streaming information that's coming at us. And then the capture piece. This is back. If we don't take all that optimization and lock it back into our ERP systems, we will lose that every gain that we've worked so hard for along the way. So in concluding, I've been involved, like I said, probably very hardcore on this subject for the last 15 years. And the last 2-3 years since my CEO, Jeff Emmelt, made that statement in his blog in 2014, this thing is picking up speed big time. It's happening faster than you can think. And all I would say is get connected now and start exploring what smart manufacturing can do with you. So with that, I'd like to conclude and take any questions you might have.
Thanks, Bryan. Thanks, Bryan. We do have time for a few questions. There's some question cards. If you can quickly put those together, and we've got some folks running around to grab those. I had one question for you, and you talk about the importance of recruiting some of this new talent into manufacturing. GE's got some great commercials out right now, and I don't know how many of you have seen those, where the guy's going to, he goes, no, I'm going to do the industrial internet, and I'm going to improve the trains, and I'm going to do that. And they're like, you're going to work on a train? Because I got this app with a kitty with a cantaloupe head on it, you know. So how do we get that message out maybe to that next generation? What can we do to kind of help make sure that we've got the right talent?
So one of the things, a passion of mine is education, and you know, I first started working with a lot of universities back when I was at Boeing, and we're not going far enough back is what I realized. So I've been involved with the technical colleges, but even getting the feeder from the secondary schools into those. So in South Carolina, I was a part of the founding members helping stand up the Upstate STEM Collaborative, and that's just part of trying to get people engaged with the whole manufacturing environment again. You know, we put together for the science fair a manufacturing award based off the merchant award that I got. I thought that was great. That's helped us fund that. But it's engagement, right? It's back to the top level of that stack where I talk about it's people and culture, and we have to engage. We have to lead. Mm-hmm. We have to connect with the people that might have an interest in it.
No, that's great. That's great. We're going to steal them from Google, aren't we? Yeah, it's a good idea. Here's a question from Kevin Moore. He says, what is the most valuable result you can achieve with an organization-wide integrated manufacturing and test data management system?
Test data management system. So all I'll say is, from a value standpoint, is we continue to build on each step of the way. You know, this outside-in strategy that I talked about, 6 figures at a time, you know, moving up to 7 figures when we did a little bit bigger, got entire plant-wide type of stuff. Where we're going when we start talking about, if you're talking about tests like aircraft testing, we have a large test stand where we run our gas turbines. It's the only full-speed, full-load test stand in the world, but that burns through, we have our own natural gas farm behind it. So I see tens of millions of dollars opportunity in working with our own test stand, improving the operations there. So, you know, each one's going to be different, but we're easily talking like the trillions of dollars as far as the revenue side. We're talking hundreds of millions of dollars. Mm-hmm. I think even within GE, if you look at our annual report and just look at our P&E and things like that, and you think about, GE talks about the power of 1%, we're easily talking about $10 to $100 million a year savings, I would say, across GE.
Mm-hmm. Yeah, and that really adds up. I saw a video recently that Boeing had out that talked about, you know, improving, I think it was the 777 fuel efficiency by like 0.5% or something, and what that really meant over time. And it's the same kind of phenomenon you're talking
Right.
about as well.
And the bigger savings is in our supply base. So
mm-hmm.
the more we can get them connected, you know, suppliers reaching out to one another to offer us something that we didn't expect. Mm-hmm. I can't put a value on that, but those are things that I want to see happen.
Mm-hmm. Mm-hmm. Here's another question from our audience. Besides the cultural challenges, what are the lessons learned during your 15-year endeavor for driving the manufacturing network connectivity?
Yeah. So anticipate, trust your expertise, your instincts, because we were opportunistic. There were events that happened that we happened to be ready to go live the next day. Mm-hmm. Right, and if you said, I'll be back to you, it's going to take me a year to develop this, or even a month to develop this, as let's say you have a compressor go down that's feeding your entire factory. They're not going to wait one shift for you to go develop anything. So those are the types of things. Trust your expertise, anticipate, and then be opportunistic.
That's great. Here's another question. What enables you to make those tough investment decisions in new technology when the ROI isn't a clear-cut decision?
Having a champion that's going to stand up and fight through that without the ROI to start with. I mean, we're doing that. It's like putting in a PLM system or an ERP system. I know they all put ROIs on those, but I don't know if anyone's ever followed up as to what they actually return. The smart manufacturing system, you're going to need a strong champion that's willing to stand up in front of people and push it forward against all odds. So.
Great. Here's another question from a member of our audience from Boeing. Do you see value in adding a weighting component to data or just deal with the larger quantity?
No, I think weighting is going to be a critical piece of the analytics. I mean, we're going to be getting data from all different types of sources, some of which are going to have a greater percentage of error than others, and you're going to have to weight those. You're going to have to find ways to build that into your analytics. Everything can't be weighted equally. That would be bad.
Yeah, that would be bad. Here's a question from probably a student, I'm thinking. It says, when recruiting out of college, which skills are most important, and are universities teaching them? And then a follow-up question. We talked a little bit about folks that are predisposed to IT, but what about non-computer scientists? What kind of skills can they develop to get involved in this new revolution here?
So I'm a metallurgist. I'm probably the last person that you would think about being involved with smart manufacturing or be the chairman for the Mechanical Engineering Advisory Board at a major university. You can learn this. You have the background. With an engineering background, they've taught you how to teach yourself. The degree and the area that you're working in, if you're just going to stay in what they taught you 30, 40 years down the road, you're going to evolve. You're going to have to get involved in new things, learn new skills throughout your career. That's why I'm so passionate about educating and re-educating yourself. So how do you get involved? There's all sorts of ways that if you don't have the background in some of these sensors, I took one elective in non-destructive testing when this company hired me for whatever reason. And then I learned on the fly, right? And so in the schools today, the first part of that question is how well are the schools? They are by far more superior than anything that I had when I was in school. I couldn't get hired today into the companies I did years ago. The students are that much better. They work better in teams. I think that's critical in these smart manufacturing things because no one can be an expert in the entire thing. So we're talking about more teaming and everyone being an expert and bringing that piece together and join it together. So, and I see a lot of universities already putting those types of programs in. I read just recently GE sponsored a new space at Michigan State University for their engineering program that allows the engineering students, they're working in cohorts or something, so they come together. There's a lot of good things going on in universities today, and they're much better prepared, and the students coming out are much better prepared than I ever was. So I'm totally confident they're going to be able to get to where I'm at very quickly.
So never stop learning, right, is the message there as well. So thanks very much, Bryan, for being our keynoter this morning. We'd like to thank him again.
Thank you for having me. I appreciate it.